Good morning and welcome to Wednesday. Thank you very much for showing up for your learning today. We have 180 rotated our heads from the back of the room, so we're back to the front again. People want to take a deep breath and go like this. And we should have enough energy to get through one lesson before we go on break. All right, everyone. We are talking about taking a line and sticking it right through your quadratic, okay? We're going to go through a parabola. This can have a lot of situations where we have no solutions, we have one solution, or we get two solutions, okay? This picture is on your handout. But one thing that this PowerPoint reminds me to do is to review linear systems first. So in grade 9, you would have practiced graphing lines and finding their point of intersection. In grade 10, you use substitution and elimination to find the coordinates of these points algebraically. And we've just done a little bit of practice with that as well. Thank you so much for the fruit. And so now we are now the place where bananas and oranges intersect. All right. We have reviewed this together as a class, and now we are looking at these situations where we now say, here is a quadratic, and here is a line. Where do they touch? Now, we can have three situations. Touch in 1 point, touch in 2 points, or touch at no points. It's a little bit similar to lines, where lines can touch at 0 points, but they have to be parallel and exactly parallel. Lines can touch at 1 point, and in fact, they always do if you have random lines because of the natures of infinities. But that means touching at 1 point. And they can touch in an infinite number of points if the two lines are the same thing, like my finger touches this marker at an infinite number of points. But that'd be the same thing. But two lines can't touch each other at 2 points. You need one of them to be a curve. And so we can finally do that right here, touching at 2 points. Now, this is your step-by-step how to do it, and this is on your handout. First, you want to rearrange both equations into y equals form. All right. Sometimes you're going to have quadratics that have like things on one side and things on the other, and it's all mixed up. You want to organize them and solve them both for y equals, and solve your line for y equals. Some of the examples we looked at today, like this example up here in up above my face there, that has lines that aren't in y equals. So first thing that I did was solve one of those lines for y, and that looked like this over there. See, I have to solve that for y, and then when I get that is equal to y, I can now do my substitution. Same thing with lines and linear systems. We're going to do that with quadratics. Then we set all the equations equal to one another, then substitute for y. So you're going to take your line, mx plus b, and set it equal to ax squared plus bx plus c. And then you're going to rearrange so that you get 0 equals that. And then we can solve it by factoring. We can solve it with the quadratic formula. You're going to solve this. And then you substitute the x values in to determine your y values. And then state your solution as points, x, y. These are the points of intersection of the system. Let's take a look at some examples. All right. So we want to have solutions to this system. And I get a little bored when my teacher sits at the front of the room and talks at me. So I'm going to stand up and do these on the board. I know that that's not going to come through super great on the video, but if you want, you can zoom in to follow along here. Okay. Oops. That is the solution. We don't want to see that. We're going to look at this. So here we go. I'm going to work up there. Good. I do too. Huh? Okay, we have x squared plus 6x plus 5, and y is equal to x minus 5. So we have two functions. One's a line, one's a quadratic. I copy them out. Y equals x squared minus 6x plus 5. And my other equation is y is equal to x minus 5. Oops. X minus 5.
Well, we need another piece of paper to work on.
Sorry?
I'm assuming we won't have enough room to just do it.
I think you might have enough room there. So here, what I do is I set the two equal to one another. I'm going to substitute that into that, and it looks like this. X minus 5 equals x squared minus 6x plus 5. All right? See, because y equals y. So I'm substituting this y in for that y, and I create this line here, a new line. Notice, one equation, one variable, solvable. Yeah, well, there's x squared, but that's still an x. Okay? Now, because it's x squared, it has the possibility of giving me two solutions, not just one, because of the degree of the variable. So that is a good observation that I have x squareds. It's going to be different than solving lines. Lines only give me one solution. Quadratics can touch at 2 points, so that gives me two solutions. Now, solve for 0 equals and all this stuff. 0 equals all this stuff. So I'm going to subtract x from both sides and add 5 to both sides. 0 equals x squared minus 7x plus 10. I did some x minus x to both sides and plus 5 to both sides. Minus x here, plus 5 here. Okay? And so that gave me this line. Do I need the quadratic formula here, or is it faster to solve by factoring? Faster to factor. Yeah. Here it's faster to factor. Recognize when it's faster to do quadratic formula, do quadratic formula. So here I have 0 is equal to x times x in the brackets, and I need these two numbers. Someone give them to me. Sorry? Yeah. What flavors of 2 and 5? Negative 2 times negative 5. All right, verify that this is true. X times x is x squared. X times negative 5 is negative 5x. Negative 2 times x is negative 2x. Negative 2 minus 5 is negative 7. Negative 2 times negative 5 is positive 10. It works. So now we know that if 0 is equal to this, what are the values of x that could make that true? Brody?
No, where did 2 come from?
The 2. The 2 was, we were on a treasure hunt for two special numbers. And let me tell you the recipe that we used when we were finding those two special numbers. We wanted numbers that would multiply to 10, positive. And we wanted numbers that would add to negative 7. If numbers are adding to a negative number but multiplying to a positive number, they both must be negative. That's the only way to do that. And plus 10, well, 5 and 2 is a way to multiply to 10. And when they're both negative, that makes negative 7. So does that answer your question? Good. Good. Jackson?
We did that last week or whatever.
Yeah.
Oh my god.
Yeah. So we're seeing it again. Faster to factor here. So what are my values of x that makes this true? What flavors?
Positive 2.
Oh, positive.
Yeah. So I can, this is the trick here that I can do. I can create two different equations and solve them here. I can say so, or therefore, 0 is equal to x minus 2, or 0 is equal to x minus 5. Okay? If this is equal to 0, then this would be equal to 0, because I have 0 times something. If this one is equal to 0, then all this is equal to 0 because I have something times 0. Well, it equals 0 when x is 2 or when x is 5. Therefore, x equals 2 and x equals 5. Okay. Therefore, x equals 2 or x equals 5. Now I need to find my y values for when that's true. How will I find those y values? I'm going to substitute them in. Yes, Dave? Okay. All right, I'm going to substitute those values in. And this is what it's going to look like. I'm going to have to do it twice. First one, x is equal to 2. So I'm going to substitute that here. It's almost break. X equal to 2, I'm going to substitute that there. First, I'm going to write this out. So when y is equal to x minus 5, first I'm going to say we'll substitute x is equal to 2. When x is equal to 2, y is equal to 2 minus 5. Y is equal to negative 3. Therefore, one solution is, notice I didn't say final solution. I'm sorry. X is equal to, I really have to stop. X is equal, so this is one solution, 2, negative 3. Find the other solution. Y is equal to X minus 5. Substitute X equals 5. And Y is equal to 0. 5 minus 5 is 0. Y equals 5 minus 5. Y is equal to 0. So, therefore, the second solution is the point 5, 0. And then I have, solved that type of problem, and I want to check my answer. So I would check it. How would I check my answer? Desmos is a great way to do it when you're on your own. So let's take a look. Oh, it so happens that this PowerPoint already contains it. So here we go. Here is the point 2, negative 3. And there is the point 5, 0. Look, that's where it touches. So we were correct. So that is one solution where we can use factoring. Now this is a more challenging one, right? We now don't have these equations solved for y, so we've got a little bit more doing to do. And I only have 3 minutes before we go on break. So should we go on break and then do this one? Yes, Mr. Jennings. All right, make sure you have your phones ready, your cameras ready, because I might posterize myself and trip here while I try and work around all these cables. But hey, life's not perfect. Here we go. So I want to solve this. What kind of shape is that going to make when I graph it? It's going to make some kind of parabola. Some kind of parabola. And this one, what kind of shape is it going to make?
A line.
That's a line, some kind of line. I don't know, I can't visualize that, and I can't visualize that because they're not in a nice form yet. So let's turn them both into nice forms, then we'll be able to visualize them, and we want to solve. So let's do the work. So let's solve this one for y equals, all right? So I'm going to subtract 12 from both sides, and then I'm going to divide both sides by 2. Okay, so I'm going to have 2y equals 4x squared minus 4x minus 12. Divide both sides by 2 to give me y is equal to 2x squared minus 2x minus 6. Now I can visualize that parabola. It has a stretch factor 2. It has slope negative 2 as it crosses the y-axis. And it has a y-intercept of negative 6. So it looks like this. Here's my y-intercept of negative 6. I know it's going down at that point. I know it opens upward because it has a stretch factor 2. So it's some parabola that looks like this. Has its vertex in this quadrant. I know that it's going to be positive x, negative y for the vertex. I don't need to know the vertex for this problem. I need to know where it touches that line. So let's try and visualize that line. All right, so this line here, 6x minus 3y plus 6 equals 0. Let's move this y over there by adding 3y to both sides. And then we will have 6x, success, yes, I love it, plus 6 equals 3y. Divide both sides by 3, because I don't care what 3y is, I want to know what y is. So that gives me 2x plus 2 is equal to y. Now, I can graph that. 2x plus 2, so it's going to be up here is the y-intercept. It's going to be quite slopey. It's going to rise faster than it runs. So it's going to touch up here in the first quadrant with a positive x, positive y. And maybe down here in the negative x, positive y. Or maybe that point of intersection is going to be down here. I don't know. It's hard for me to predict that. It's almost certainly going to be maybe at this, right on the x-axis. Yeah.
You said you could run on the board.
I'm going to try today, and if I destroy this board, I will say, oops. That's my plan. That is my sophisticated plan for this. I've tested down here. It erases fine. I'm not going to leave it on overnight. I'll erase it soon. Okay. So, also the smart board technology, we don't use that. So it's like useless if I can't write on it. So I'll try it. Okay, so now I have y equals and y equals. I can substitute this into here. So let's do that. Can someone is standing next to the, David, can you pass me that black marker? Throw it in a parabola towards me, okay? Not in a straight line.
Thanks, Boss.
Here we go. Y is equal to, I'm just going to bring my equal sign a little bit over here so I have a little bit more room. I wasn't planning on that sketch. Equals 2x minus 2x squared minus 2x minus 6, okay? And this over here, 2x plus 2. I want this 0 equals all the x's on the other side. But notice, one equation, one variable, solvable. Can give me as many as 2 solutions, or 0 or 1, because it's a quadratic. So throw this over to this side. So I'm going to subtract 2x from both sides and subtract 2 from both sides. And if you're saying, Mr. Jennings, why didn't you just do elimination? And you would have saved that. You would have written this under here and subtracted it. So you would have y minus y equals 0. And then you would have subtracted this from this. Yeah, substitution and elimination are the same thing. They're just dressed up in a different way, okay? So sue me. I didn't do it the most efficient way. So sue me, okay? Sue me. Yeah, sue me. 2x minus 2x is minus 4x. This is 2x squared, sorry. Minus 8. Okay? Now, I can factor that and solve if I can factor, or I can look at it and say, what can I do to this equation to make it simpler to work with? Faith? Yeah, just divide by the 2. So if this is equal to 0, then it divided by 2 is also equal to 0. Because 0 divided by 2 is still 0. So I'm going to divide both sides by 2, yeah?
Do you have to divide by 2?
No, I could plug it into quadratic formula here, no problem. But I can also divide by 2. Watch this. When I divide this by 2, 0 divided by 2 is still 0 equals. When all this is divided by 2, it's still not going to change this side of the equation. So having equations that are equal to 0 are nice because you can multiply them and divide them by whatever you want. And it doesn't change the other side of the equation because 0 divided by or multiplied by whatever is still 0. So 0 equals x squared minus 2x minus 4. So there, if I wanted to, can I factor that? Two numbers that multiply to negative 4 and add to negative 2? Yeah. What are the numbers, Rylan?
Oh, I don't know. I just don't
Multiplies to negative 4 and adds to negative 2.
Oh, negative 2 and 2?
Negative 2 and 2 will do it. If we didn't spot it, we would use quadratic formula at this point and we would still get an answer. And I would still give you full marks. Yep. Oh, well, I divide 0 by 2, it gives me 0. And I divide all of these terms by 2, and it makes it simpler. No. No. Do you want to see how I would solve it at this point?
Yeah.
I would look at it and I would say, that's hard. Let's use quadratic formula. And if you get the feeling, I really want to use quadratic formula here to show you that it will give you the same answer. So 0 is also, let me finish this solution first, and then I'll carry on from here. If I don't spot this, how would I still solve it? So 0 is equal to x plus 2 times x minus 2. This tells me that x is what two values?
Negative 2 and positive 2.
Yeah, negative 2 and positive 2. I just flipped the signs, but even if I forget to flip the signs, I'll still get the right answers here. Negative 2 and positive 2. Okay, cool. So that I'm sorry. This doesn't give me negative 2 here. We can't factor that.
Oh.
They add together to make 0. This is not the correct factorization.
Oh, yeah, right.
Yeah, so we do need quadratic formula here, just as I expected. I was like, I really want to use quadratic formula. Really, really use it. Really, really, really. Oh, here's my weight. That's not correct. I need quadratic formula regardless. Not perfectly, but with a bit of spritz it will come. So Cameron, do you want me to use this equation or that equation when I use quadratic formula? First one, so let's use this in our quadratic formula and find out what the possible values for x are that will make this true. So I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can memorize it or you can derive it. Deriving it with completing the square is quite challenging. I'll show you later. All right, now, this one, I just plug in my values. I can use these values or I can use these values. So let's use these values and say we didn't spot that we could divide by 2. So I have x is equal to negative b, so that's negative 4. So that's 4. I flip the sign, plus or minus the square root of 4 squared is 16. Negative 4 squared is 16. Minus 4 times a times c. A was 2, c was negative 8. So I have negative 4 times 2 times negative 8. I have 2 negatives, so I will have a positive number there. So this is 16 plus. I just count my negatives first, and then I sort that out, get the sign right. Then do your number. 4 times 2 times 8 is 64. 16 plus 64. Okay? All over 2 times a, which is 2, so that's 4. Notice that my factors are going to pop out here, okay? Now, x is equal to 4 plus or minus the square root of 16 plus 64. 16 plus 64 is 80. All over 4. What is the root of 80? If I gave you that and I asked you to simplify it, what would that look like? Let's write it out over here. Just I might have a little bit of scratch work here where I write out the root of 80 and I want to simplify that into a mixed radical. Suraj.
16 times 5, which is 45.
Yeah. 16 times 5. So 80 is 2 times 2 times 2 times 2 times 5. That's another way of saying 80. Or 8 times 10. 8 times 10 doesn't really help us that much, though, because 8's not a square, 10's not a square. But if I take the factor 2 from the 10 and bring it over to the 8, that gives me 16 times 5. 16 times 5 is really useful. That's now 4 root 5. Okay, so now when I write this here, x is equal to 4 plus or minus 4 root 5 over 4. Notice here, Cameron, we could have divided by 2 here, and that really would have simplified our work. We would have been using these numbers. But here, it doesn't make much difference if our work is correct anyway. The 4 is going to cancel out. So 4 divided by 4 is 1. 4 root 5 divided by 4 is root 5. The 4's cancel everywhere. So I have this is equal to, x is equal to 1 plus or minus square root of 5. Those are my 2 solutions for x. Notice that the square root of 5 is a non-rational number, so there was no way to factor that over here. We were incorrect to use this factorization, and I got carried along with that too. That's good. So those are my values for x. Now I substitute those in for y to solve for what the y values are. So now, where am I going to do that? Well, I can do that here with this equation. It's going to be the simplest one, right? This one that we created here. So let's use this equation. Put this over here. I'll bring my wipey, and we'll see how successfully this erases. Not bad, not bad, not bad, not bad, not bad. Okay. All right. And let's write this formula again. 2x plus 2 equals y. Now substitute in one x. X is equal to, remember I have 2 x's here. X plus root 5 and x minus root 5. So let's do x plus root 5 first. X equals 1 plus root 5. So substitute that in there. 2 times 1 plus root 5 plus 2 equals y. So y would equal 2 times 1 is 2. 2 times root 5 is 2 root 5. 2 plus 2 is 4. So this gives me 4 plus 2 root 5 is equal to y. That's an exact answer for y. And then I want my other one. So this is one of my x's. Let's find the other x. X is equal to 1 minus root 5. And that would be, I don't know if you could see it, but it's going to be 4 minus 2 root 5 is y. But let's calculate it, because sometimes it's not that easy. We're going to write this again and substitute. 2, so this is my other x. This is solution number 1. This is solution number 2. Okay? So here, I have 2 times 1 minus root 5 plus 2 equals y. This would be 2 minus 2 root 5. This is 4 minus 2 root 5 equals y. And there's my other solution. Now I just need a therefore statement. I'm going to put it over here. Therefore, the points of intersection are, my first one is my first value of x plus root 5, sure, are 1 plus root 5 in the x, and the y for that one was here, 4 plus 2 root 5y. 4 plus 2 root 5, okay, and 1 minus root 5 in the x, and my y was 4 minus 2 root 5. So, remember when I told you it's going to have one intersection that's over here, that's both are positive? That's this one. 1 plus root 5 is going to be bigger than, well, root 5 is a little bit bigger than 2. So this is a number, 1 plus root 5. That's just 3 something something something. If you convert it to decimals, you'll still have a good understanding of that number. But now this is an exact answer. And so that intercept is over there. 4 plus 2 root 5, that's like 4 plus 4 and a bit. So that's happening up there at 8 or 9. Up there, between 8 and 9. And this intercept actually happens where x is negative and y is slightly negative. Y, this is happening barely down there, that intercept. This comes down and touches just down here, where both are negative. And those are our 2 interceptions for that system. Yeah! So, sorry, that took forever? I was talking a lot. It doesn't take you that long. It won't take you that long when you're working without that. And let me take a photo. I'll put the photo up because I know that this is not coming through well on the video.
And are you going to post that on the D2L?
Sure.
Awesome, thank you.
There we go. Okay, so now let's do another question. Oh, we have an hour. Sorry?
In the last thing that you did, where's
Yep.
the 4 from?
Where'd I get the 4? This 4?
Yeah, and the one above
Not 4?
Yeah.
So 2 times 1 is 2, plus 2 is 4.
Oh.
2 plus 2.
Oh yeah, because the 2
Dave?
can't go with the 5, right?
Yeah, we can't, it's like combining apples and oranges.
Okay.
How do you get x equals 1 plus root 5?
X equals 1 plus root 5. Oh, I found that with quadratic formula. 4 plus or minus 4 root 5 over 4 is the same thing as 1 plus or minus root 5. 1 root 5. The 4's cancel here, the 4's cancel there, leaving you 1 plus root 5 and 1 minus root 5. That's my 2 solutions. So the x values of the intercepts are 1 plus root 5 and 1 minus root 5.
Okay.
And so it corresponds to the thing we visualized, because we've been practicing visualizing ax squared plus bx plus c, and we've been practicing visualizing y equals mx plus b, so that helps us predict our answers. Okay, I have a picture, so I'm going to erase. Oh, it needs a little bit of scrubby scrub, but it does come off. And do people like it when I do this question on the board with chalk or over here on the whiteboard?
Personally, I like the board with chalk more.
Yeah? Do people also agree?
Yeah, I
I like both.
Yeah.
Okay, I'll do the next one on chalkboard.
Thank you.
You're welcome. And this will be an experiment that we don't need to repeat, and I'll tidy that up later. There we go. Okay. I did not, I will point out, fall on my face.
That's good.
Yeah, I'm pretty proud of myself. You got to take your victories where you can get them and make sure that you celebrate all the good things in life. All right. So our next question here. Bloop, bloop, oops. There. Oh, so if I go back, there it shows us the graph, right? And this graph was what we predicted when we were looking at it. It meets at the points 1 minus root 3, sorry, minus root 5, which is down there, and 1 plus root 5, which is over here. A little bit bigger than 3, but not much bigger than 3. So that's correct. Yeah. Now, over here, we have the price of two stocks, and one of the stocks is modeled by a parabola, and the other one is modeled by a line. We see A of x is a parabola, B of x is a line. So let's find out where these two touch. First step, write out my functions. X squared is 0.75 x squared. This is A of x? A of x, yeah. This is one stock price. Is equal to this plus minus 6x plus 20. So write it out at the top of a piece of paper. And then I have B of x is equal to, someone read it out for me. Someone read it out for me.
B of x equals 2.75x plus 1.5.
Good. So where A of x touches B of x, A of x equals B of x. That's the definition of they touch at that point. The two functions equal each other at those points. We know that this could be as many as 2 points, so let's find out what they are. We're going to make A of x equal B of x. So we could write A of x equals B of x. Right, write out our functions. We say they touch at the point of origin. At the point of intersection. And then I can write them out. So A of x is 0.75 x squared minus 6x plus 20 is equal to 2.75x plus 1.5. All right, now I was told put everything to one side and make the other side equal 0. Okay, so let's subtract this from that side and move it over here. And then we have all this is equal to 0. Doesn't matter if we have 0 equals blah, 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 or blah, blah, blah equals 0. Same thing. So I'm going to subtract 2.75x minus 1.5. And you might be saying, hey, you could have used elimination. I say, yeah, sure. Okay, if you want to set it up that way, you go ahead. 75x minus 1.5. There we go. So now, this side's going to be equal to 0. Hurrah, that was our goal. This minus that is 0. This minus that is 0. And then when we do the same thing to this side, we didn't change our x squareds.
No.
We didn't add or subtract x squared. So we still have 0.75 x squared. Minus 6 minus 2, that is minus 8.75 x minus a minus.
Yeah, I didn't see that.
Yeah. So always careful with our signs. It's a very common place to make an error. 20 minus 1.5 is a plus 18.5. Okay. Now, quadratic formula. I don't want to factor that. Ain't nobody got time for that. Okay? Use the quadratic formula. So, my quadratic formula here, I'm just going to start another line up here. Boom, x is equal to, you use the quadratic formula when you have a quadratic is equal to 0. That will solve for those values of x. That's what quadratic formula does. Okay, so it's designed for this exact purpose. So I have it's a negative b plus or minus the square root of b squared minus 4ac. Now I might forget that sometimes, in which case I'll just Google it, okay? Now, x is equal to, or you can learn the song, the quadratic formula song, and always remember it. All right, so here, negative b is positive 8.75. 8.75 plus or minus b squared. So 8.75 squared is going to be a little less than 81. What is it? I don't know. I don't want to do that in my head. People should have calculators out and be shouting answers at me. making me do my own calculations. Shame on you.
Got it.
76.5625. 76.5625 minus 4AC. 4 times this is 3 times this is 3 times 18.5. 3 times 18.5 is that's going to be 60 is 55.5. 55.5, right? 55.5. So that's 55.5. Okay. So there, that's my 4AC. Negative 55.5. Okay. And then all over 2A. So 2 times this is 1.5. All divided by 1.5. All right. Let's simplify this. So x is equal to 8.75 plus or minus. You're like, Mr. Jennings, why didn't you round that? Meh, I just leave that ugly number on my calculator so I don't have to round yet. I'll round at the final answer. Okay, so I take this number, I subtract 55.5, it gives me 21.0625. And now I'm going to take the square root of this number, okay? So I'm just going to go shift that, boop, and that tells me it's 4.589. So that's 4.6. 4.589, that's 4.6. I'm going to keep one decimal place. So this is 8.75 plus 4.6 plus or minus 4.6, all divided by 1.5. All right. So now I still really don't have a good sense of what that number is. So let's figure it out. All right. Let's do 8.75 plus this. So I'm going to say plus 8.75 equals 13.33 divided by 1.5 equals 8.9. X is equal to 8.9, or, and then I have the minus. So I have 8.75 minus 4.6 equals 4.15 divided by 1.5 equals 2.76 repeating. So 2.8 or 2.8. So those are my values of x. That's where this line will cross the parabola. Now I need to find, so those are the prices. State all prices to the nearest dollar where both stock values were the same. X equals the number of months. So that's how many months will go by to make the stock values the same. I now need to find the prices. The prices are my y values. They're the values of the function. So let's say, yes, Ryan. Yes, Ryan, you may go to the washroom. So x is 8.9 months. So it's a little bit less than 9 months. The stock value is the same. So let's find out when that happens. We'll use b of x, much simpler. So b at 8.9. Notice how nice function notation is here. I put my input right there, is equal to 2.75. 2.75 multiplied by 8.9 plus 1.5. Okay, so now I do 2.75 times 8.9 equals 24.47 plus 1.5 equals, I have a stock price of $26 here. It asks me to round, so 25.9, 26. It says B at this is equal to 26. Understand which? No, it's not a question for me. So I substituted this in for x, so I write it in my function notation. I have the equation of the line, and I put in the value for x there. When I multiply this times this, and then I add that, I got 26. And that's something I don't do in my head, so I'm not writing down my steps. I just do it on calculator. Follow Bedmus. And then I also need to evaluate b at 2.8 is equal to 2.75 multiplied by 2.8 plus 1.5. Again, do this on your calculator. So 2.75 times 2.8 equals plus 1.5 equals 9.2 equals 9. Okay? Therefore, the two stock prices have the same value when they cost $26 and when they cost $9. This is a parabola opening upwards. This is a line that's growing. So here's a very quick sketch. Here's the stock price of one of the stocks. Here is the line stock price. This value was $9. This value was $26. That's what we found there. The two stock prices, the quadratic one will be worth less in between those, but it'll be worth more after that point of intersection, and it's worth more before this point of intersection. Jackson.
So how come it's 8.9 or 2.8? Where's the price? Oh, for the negative and positive.
Yeah, from the plus or minus.
And on a test, if we had a question like this, you want to do both.
Unless I told you that there were restrictions on the domain. So if I say, if you found that one of these intersections was in negative time, like in the time before we start the clock, then you would say these stock prices would have been the same in the past, but we're not interested in that. We want to know when they're going to be the same in the future. So there would only be one solution. Like the domain of x is greater than 0, like time is only going forward, we're only interested in the future, would determine that only one of those solutions is meaningful. But in this case, yeah, it says determine the state all prices to the nearest dollar where both stock values are the same. So we know that there's probably two solutions to that question. And those would be the two solutions.
Wait, what would be our therefore statement?
Therefore, the two stocks are the same value when they cost $26 or when they cost $9. And it didn't tell me to specify when, but I would say after 9 months, the two stocks are worth $26. But after about a little less than 3 months, they're worth $9. And those are the two times where they cost the same amount of money.
Wait, sorry, the two stocks are what?
The two stocks have the same value when their value is $9 or $26. So here, you see, there's our first solution, there's our next solution. At 26 and at about 8. So,
At about 8. I thought it was 9.
sorry?
We got 9.
Did we get 9?
It was 26 and 9.
Yeah, I just did. Yeah, I'll post them on the D2L in just a moment. So one last thing to look at. Once we have this system in the form 0 equals ax squared plus bx plus c, we can use the discriminant to determine the number of solutions. Okay. The discriminant is this thing b squared minus 4ac. If there's no solutions, and we look at the discriminant here, see this part in here, b squared minus 4ac, this part of the quadratic formula is called the discriminant. And it's, what's happened there? That's like paused. Something has gone on. Anyway, maybe this video will not work. B squared minus 4ac, when that's less than 0, meaning when it's negative, I can't take the square root of a negative number, so I have no real solutions. That's the situation described by this picture here, where the parabola is missed by the line. The line never hits it. If the line kisses the parabola at one and only one point, that's where the discriminant is 0. Because then I would have the square root of 0 is 0, and my two solutions are plus or minus 0, meaning there's no difference between the two solutions. Plus or minus 0 is the same thing as saying, hi, I'm Grant Jennings. I'm 41 plus or minus 0 years old. If I don't want to give you my exact age, I'd say I'm 41 plus or minus 5 years. Like maybe I'm somewhere in there and I want to keep it mysterious. But if I say 41 plus or minus 0, you know my exact age. And that'll be true until the end of the course. At the point I'll start saying 42. Okay. So that's if the discriminant is 0. I have one and only one solution. If I have two solutions, that means this is plus or minus a positive number. That means that's bigger than 0. So that's how I can use the discriminant to determine what situation do I have. Do I have no solutions? Do I have exactly one solution? Or do I have 2 solutions? So if I want to know how many intersections to this system, then I would put them together, look at my quadratic formula, and find the discriminant. And that's going to tell me how many solutions. So let's do this one together, and then I'll release you to do the homework and the different assignment questions and discussions. It's on the D2L. I forgot to put it on your handout, but I'll write it on the board in just a second. It's like the next thing I'll do after this. Aren't you glad we have all day tomorrow and the first part of the class on Friday to review before we have to test any of this? Don't you want to get ready for that tonight by finding your most important, your most pressing questions about this whole unit and ask me those questions tomorrow? Yes, good. Yeah, I'll give you a review page tomorrow. Y minus x squared equals, so someone read it out for me. Y minus x squared equals what? 7 minus 5x. Okay, that's my first equation. And my next equation was what? 4y minus 8x equals 21. Okay, first thing I'm going to rearrange this equation to solve for y.
Negative 21.
So, negative 21. Thank you very much. So I get a different answer. All right, solve for y over here. So I have 4y is equal to 8x minus 21. I added 8x to both sides. Now I divide by 4. Y is equal to 2x minus 21 over 4. Okay? There's one of my equations rearranged. Now I can use substitution. I can substitute it right in there. That's fine, and then rearrange. Or I could rearrange and then substitute. Both are fine. Dave?
Where do you find that?
That?
Where do you find that question? You don't have it.
It's right up there. Yeah, I didn't put it on the handout for some reason. I was like, oh, we'll do this one, but I wanted this to be a one-pager, and I wanted you to have space for that. So anyway, this one is faster because we're just using the discriminant to find out how many solutions. We're not actually finding the solutions.
Okay.
So here, this is my y. I'm going to substitute it in there. So I have 2x. I'm going to put this in brackets. 2x minus 21 over 4 minus x squared is equal to 7 minus 5x. Move this over here. Okay? So I'm going to subtract 7 from both sides and add 5x to both sides. Minus 7 plus 5x to both sides. Minus 7 plus 5x. Okay. So negative 21 over 4 minus 7. This would be negative 49 over 4. Because negative 7 is, negative 7 over 4 is, negative 7 written as a fraction over 4. If I have 7 pizzas and I quarter them all, I have 28 slices. So 7 is the same thing as 28 over 4. So when I'm going to rewrite that. This is 7x. This is negative 21 over 4 minus 28 over 4. Okay. And then this is negative x squared. I'll put that out here. Negative x squared plus. All right. And that's all equal to 0. I'm almost there. I just need to put these together. And so negative 21 minus 28 is minus 49. Cameron? About which line? Yeah.
Like I get that you move 7 and 5 over.
Yep.
Like I understand that, but do you multiply that by the bracket?
No, I'm adding. I have 2x plus 5x.
Okay,
Because
bracket.
here, what I'm doing, and I have to do the same thing to both sides of the equation. That's always true. So if I have like an elephant is equal to 1,000 pounds, and I add a person on this side, and people weigh 200 pounds, okay? If I had one person on that side, I need to add one person on that side to balance it.
I think you should.
And an elephant plus one person would be 1,000 pounds plus one person. So I'm adding the same thing to both sides. So when I add that to this side, I just now collect like terms. Right? So I'm collecting like terms, gives me 7x. I collect this and this gives me, just going to grab this. Therefore, this is negative x squared plus 7x minus 49 over 4 equals 0. Do people like to have more or fewer negatives in your question? Fewer is a little better, right? So let's multiply both sides of this equation by negative 1. X squared minus 7x plus 49 over 4 is equal to negative 0. Looks like I can flip all the signs. I can just flip all the signs and it's the same, because when I flip the sign on this side, it's the same thing. Negative 0 is 0. There's no such thing as a negative 0 or a positive 0. So these are the same. Now I can use my discriminant to find how many solutions will there be to this linear system. So I know that the discriminant is b squared minus 4ac. So let's find that out. B squared here, negative 7, that's 49. Well, let's just sub in. So I'll write it out. 7 squared minus 4 times a, which is 1, times c, which is 49 over 4. Oh, nice, eh? So what's this discriminant equal to? It's equal to 49 minus 4 times 49 over 4. These 4's cancel. That gives me 49 minus 49 equal to 0. That tells me how many solutions are there to this linear system. There is one system, one solution to this system. When the discriminant equals 0, that's the one situation where we have one and only one solution, where the line just kisses the parabola and leaves, just touches it once. If the line touches the parabola twice, we have a positive discriminant. If it misses and doesn't touch the parabola, we have a negative discriminant. We can't use quadratic formula and get real solutions. Oh, okay. So